Hello guys, I hope everyone is doing fine. At the request of some of you, I am now going to solve this exercise, which is 1-4 on the handbook that I provided to you a few days ago. And it says the following. The standard normal distribution is given by this expression, where z, the random variable, is in the range of minus infinity and plus infinity, as you can see. So here we must show that the expected value of z is equal to 0 in this case. Alright, so how do we go about it, guys? Let me first write down solution. Good. First thing is we need to remember what the expression is for finding the expected value of a random variable, z in this case. By definition, we know that the expected value of z is an integral whose limits are minus infinity and plus infinity of z times f of z dz. As you know, this is the general expression for finding the expected value of a random variable. This expression should all be familiar to you, but if that is not the case, then I would strongly advise you to please review the material or ask many questions if you should have any. Alright, so let me just copy the integral and z. Okay, now here I'm going to make a replacement. I know that by the information that I was given before that f of z is this expression. So let me replace that. This is going to be 1 over square root of 2 pi exponential of minus z squared over 2 dz. Okay. So here I have a constant. Let me take it out for convenience. So this is 1 over square root of 2 pi times integral minus infinity plus infinity. And here I'm also going to transpose these two terms without affecting the original expression. So this is the same as exponential of minus z squared over 2 times z dz. Alright, so in order to convince you about the next steps we have to follow here, let me find the derivative of this expression, of this exponential function that we have here. So let me define f of z as exponential of minus z squared over 2. What is the derivative of this expression? Let's find out. So the derivative of f of z in this case is just this exponential. Let me write it down again, times the derivative of this part. All right, the derivative of the exponent that we have over here. So what is that going to be? That is minus 2z over 2. Okay, so by simplifying, this and this will cancel out, and here I will have minus exponential of z squared over 2 times z. Now, if you look closely at this expression we have here, it's basically the same as this one we have just found, except for the sign. All right? So what I'm going to do here is I'm going to multiply this expression by minus 1 and then by minus 1 again. If I do that, I'm not going to affect the original expression. So let's do it. So this is minus 1 over the square root of 2 pi integral minus infinity plus infinity of minus exponential z squared over 2 z and dz. All right, So again, here what I just did is to multiply this expression by -1 and then by -1 again. I am not affecting the original quantity by doing that. Cool. If you look at this, you will see that this is exactly the same as this derivative we found at the beginning. So what does it mean for us? Let me just write it down again. This integral is going to be just the exponential of minus z squared over 2. That means the original expression we had here. Because as you remember, an integral is just the primitive function of a derivative. So that's what we're finding here. And now I'm going to replace the limits as well. And let's continue. Cool. Now all we have to do is to replace the limits of the integral. So let's go ahead and do that. So this is -1 over square root of 2 pi. And here I will have exponential of minus z squared. And that is going to be infinity squared, which is just infinity. So this is going to be minus infinity. Now, so this is minus exponential again. And by replacing minus infinity squared is going to be infinity anyway. All right? So this is going to be minus infinity as well. All right. So exponential of minus infinity is just 0. So this is 0, and this one will also be 0. If we multiply 0 by this expression, by this constant, then eventually we're getting 0. And with that, we have just shown that the expected value of z in this case is equal to 0 as requested. Alright guys, so I would strongly advise you to please try to solve more of these proof exercises. It is a good way for you to get more practice and to understand more about the density functions that we're studying here in classes. If you have any questions, please let me know. I will be more than happy to assist you with any issues or concerns you may have about your exercises. That's it for today.